with us. We have some corporate bodies. We also have some companies also joining us here, which is great. So we have friends from SPDC, that is Shell Petroleum Development Company. We have those from Total Energies. I also noted some from the National Maritime University. We have the LOG and University of Port Harcourt. I can also see even right now. As they come along, we will get to mention, some of them or all of them if we can, as the meeting progresses. So at this point in time, we would like to go to the first item on our agenda, which is going to be an opening prayer that will be taken by the AGS. So our AGS, are you ready to have the opening prayer? So Mrs. Tina, are you ready with us?
Yes, I am. Good morning, everyone.
All right. If it's okay, you can have your videos as well so that everybody can see you. Great.
Okay. Good morning, everyone.
Good morning.
My name is Miss Augustina Egwon. So please, can we quickly have our opening prayer to officially kickstart the presentation? Thank you. We pray in Jesus' name. Father, we thank you. We worship you. We give you all the glory for this great opportunity. We ask, oh Lord, that you take preeminence of this presentation. We pray, oh Lord, for a successful and fruitful presentation. And we also thank you for answered prayers. We pray, oh Lord, that our gathering this morning will not be in vain, but we pray for a fruitful completion of this presentation. For in Jesus' name we pray. Amen.
Amen. Thank you so much, Mrs. Tina, our Assistant General Secretary, for this opening prayer, which guides us into today's meeting. All right, we will now take a safety moment. Safety is a very core part of our business. So we'd like to take a safety moment, which will be brought by our Publicity Secretary. So hand over to the Publicity Secretary to give us safety moments.
Yeah, good morning, everyone.
Good morning.
Yeah, good morning. Welcome every one of us to this very important technical meeting. Sorry, my video cannot open because of network challenges over here. Please pardon me. Apologies. So as NAPE, we are also champions when it comes to ensuring the safety and in our workplace, in our business, in our environment. And we're also frontiers in the energy sector. As part of our safety measures, which we want to address everyone this morning, we know this is a virtual meeting. And so we know that most of us are connected from different locations. Some of us from the office, some of us in the business place, some of us at our homes. We want to ensure that as we connect, despite our location, ensure that, especially for those of us who are in the office, you want to stay in a place where there's light, that you can take notes as the lecture is going on, and there's no interruption where you are too. Number two, also take note here that some of us will be at home, and we are attending to one or two chores at home, cooking and the rest. So please ensure you put off your appliances so that you won't be distracted while cooking. Your stove is on, or your heater is on, or your press iron is on. These are safety measures we want to take note as the meeting will unfold for the next 1 hour or so. Then if you are driving, it's best you also park, possibly so that you can benefit. It's not advisable you drive while this lecture is going on. So you park, you take notes, so you can benefit from this important lecture that will take place in a few minutes from now. Those are the few measures we need to take note of, and other ones will come towards the end of the section. Thank you all. I believe we are going to enjoy this program. Thank you all.
All right, thank you, Dr. Kingsley, our Publicity Secretary, for those very important words of safety, particularly the last one. Please, if you're driving, take that break and follow the event, and then you can get to your destination later. All right, we'll go to the next item on our list, and it's an important part as well. We would like to call on the leader of our section, the chapter, the coordinator of the Port Harcourt chapter of NAPI, Mr. Magnus Abbey, to give us his address. Mr. Magnus, please.
Right, I know most people are laughing their heads off right now, the way the APCC introduced me. Confirm you can hear me clearly, please. My name is not Magnus Abbey, my name is Magnus Kano. But that's a family we've created for ourselves, and we enjoy ourselves and have fun. So I like to echo, but can you hear me? Can you see me? Maybe my video.
We can hear you perfectly.
Okay. But is my video working? I hope it works. Now, if it doesn't work, you make do with my voice. But just to echo they already said welcome to everyone to this technical/business meeting for the Nigerian Association of Petroleum Explorationists, Port Harcourt chapter today. We are very glad that this meeting is eventually holding. This happens to be the first under this new ESCO, this new administration. You recall that in the month of March, an election was done, and a new set of executive members officers were elected to lead this chapter. We want to take this opportunity to really thank and commend the immediate past executive officers, led by the very charming, dutiful, diligent, and amiable Mr. Emo. Mr. Emo had been very fantastic. For people who don't know, Mr. Emo had led this, been in the leadership of this chapter since sometime 2006. And in 2019, he became the chapter coordinator. Such a long period of meritorious service. What more can we say? But to say, may God, bless and reward your efforts that you put in, your resources to lead this chapter to the level where we are right now. And we are here trusting God, riding also on your support and experience to take this association, the Port Harcourt chapter of it, to the next and higher level. And just by way of introducing this is NAPI. We are part of a national body, like we've tried to introduce it, and we have a vision, which is to be the preferred professional petroleum geoscience association with a global reach. And the reason for saying this is for us to continue to enhance and build on that sense of pride that we have already in being members of this great association. And we have a mission, actually, to maintain, grow, and promote a non-profit petroleum geoscience association for the benefit of its members and industry players and other key stakeholders. And just for you to know that NAPI is the largest professional association of petroleum geoscientists and related disciplines in Nigeria. So we have our pride of place. And the members include, which we're going to talk about in greater detail towards the end of this meeting, geologists, geophysicists, who have consultants, who have students and academicians, and of course, most of the international oil companies and national oil companies are also corporate members of this body. And NAPI, for your information, American Association of Petroleum Geologists, that's AAPG, and the EAGGE, they have a joint long-term partnership collaborative agreement to promote the practice of geoscience among the members all over the world. So you can never lose, you can never be disadvantaged being part of this association. This, by way of teeing it off, is a technical meeting. Let me not steal the shine. We have an interesting topic to get into today, rub minds together, sharpen our technical and professional, skills and knowledge. So we're excited today, and this is my way of saying a warm welcome to you. And I pass back the microphone to our able anchor, the APCC, Mr. Momudu. Take it away, please.
All right, thank you, Mr. Magnus, maybe I had a dream last night about your political exploits to come. So
They have
yes,
said that
Magnus
before.
Kanu
You're
is
prophesying.
our coordinator.
Right.
All right. So thank you for those very, very clear and detailed and I must say impressive words about the past and the future of NAPE in Port Harcourt. And we believe that great things will come for us here in Port Harcourt and for the whole of NAPE. So I would still like to take note of those who have joined us. I have some persons here, some corporate bodies. So I have Sterling Oil Exploration and Production. Thank you for joining. We also have here some persons from Maritime Support Services. Thank you for joining us. University of Port Harcourt, we had mentioned, as well as the Niger Delta University. So we thank all these persons. And we also know that some persons might be in groups behind the Zoom sessions they have, maybe not one person as a group. It'd be nice to know those who probably gather together to view and to follow this technical meeting. You could also state it in the chat box that you are not alone. You are there with like 5 people or 10 people, or maybe your entire department. It will be good to know as well for us. All right, we'll go to now one of the major parts as well of our meeting this day. And there is someone here amongst us who is going to anchor this technical session. He's going to be the moderator. He will also guide the Q&A. So I would like to introduce him properly before he takes the stage. Now, he is Dr. Meshach Omudu, and he is a seismic processing geophysicist, and he started as a PhD research intern on advanced avio analysis project. Later, he joined as a reservoir geophysicist in the team as a QI geophysicist. And now he's moved on to seismic acquisition as operational geophysicist, and currently in seismic processing with the Shell Petroleum Development Company. Please I'd like us to welcome Dr. Meshach Omudu as he anchors this session, and he will also introduce this technical speaker and presenter for today. Dr. Meshach, over to you at this point.
Thank you very much. Confirm you can hear me?
Yes, we can hear you perfectly.
All right, thanks so much. I'm excited to be a part of this experience, and also happy to introduce our speaker today in the person of Dr. T. Dagogo. Dr. Dagogo is a research geophysicist and a lecturer at the Department of Physics, Geophysics Research Group. He has about 10 years experience, and his experience spans all the themes you can think of: seismic processing, interpretation, reservoir characterization, time-lapse seismic, amongst others. And his core interest is actually in geomechanics, geophysical modeling, and simulation. He graduated from the University of Port Harcourt. He has a BSc and an MNc, and also holds a degree from the Imperial College London, where he also holds a PhD in applied geophysics from the University of Port Harcourt. He's, according to him, he's an ardent seeker of God. I think everybody here is an ardent seeker of God. He's an enthusiast and a lively member of society. He's also, he takes lectures at the Center of Excellence, University of Benin, and is happily married, and is blessed with he's blessed with children. All right, so I would be taking this session, moderating it on behalf of NAPE. Dagogo, you've got 25 minutes to do justice to what you have for us today. And he's going to talk to us on resolving the mathematical paradox of seismic wave velocities. And he postulates here that he has a formulation because there seem to be some inconsistencies between theory and practice when you look at seismic velocities and equations that relates to it. And he's postulating a formula, or he has postulated a formulation that tends to reconcile these discrepancies that we see. And it's much easy formulation that suggests that by measuring the density of material, it may be possible to predict the elastic moduli and other parameters of interest thus it takes away the need for very sophisticated and expensive, experiments. So I will yield the floor now to Dr. Dagogo to please drive the discourse. I would interject when it is 10 minutes to the 25 minutes. And then if you have questions, please do post them. And then after his presentation, we'll have 10 minutes where we can take all those questions. So I yield the floor to you, Dr. Dagogo, please go ahead.
Thank you very much. So please just give me a few minutes to share my screen so we can get into the presentation. So confirm you can see my slides in presentation mode. Okay.
The slide is open.
Okay, thank you very much. Let me say a big welcome to everyone that has joined us for this month's technical meeting. And then permit me to appreciate the NAPE for the opportunity, particularly the Port Harcourt branch of the NAPE and the executives for giving me the opportunity to make this presentation here. I'm really excited to be doing this. Also permit me to appreciate my co-researchers who have granted me permission to also share our thoughts here. In person of Dr. Balogun Ayomide and Mr. Andrew Muzan. Okay, so having said that, we'll go right into the presentation. So this morning, we're sharing a thought which we have titled Resolving the Mathematical Paradox of Seismic Wave Velocities. And to go through this presentation, we are going to be seeing the following outline. Okay, this is the outline we're going to run through for this presentation. Okay, so by way of introduction, let me say, like I'm sure we all know, that seismic velocities are very vital as far as hydrocarbon production or exploitation is concerned. Seismic velocities are an integral part of seismic surveys. Like we know, it runs through almost the entire spectrum of the seismic analysis spectrum, ranging from your statics correction to statics and dynamics corrections, to your time to depth conversion, migration, imaging, quantitative interpretation, pore pressure prediction, geomechanics, just to mention a few. But seismic velocities play a very important role as far as our seismic analysis is concerned. Okay, so seeing how important seismic velocities are, we think it's really important that we have a very good understanding of seismic velocities, and also we think it's okay, or it's in place for us to reevaluate our understanding or perspective of the quantity from time to time as our knowledge improves. Okay, so that's the philosophical background behind this endeavor. Okay, so permit me also to draw our attention to the harmony that we find existing between physics and mathematics. We know physics and the two disciplines of physics and mathematics are very interwoven, to the point that it won't be out of place to say mathematics is the language in which physics is communicated, or you can say mathematics is the language in which physical phenomena is described. Okay, so but particularly in this presentation, we are interested in one of the mathematical concepts that we all know, the proportionality concept. Okay, under which the mathematical proportionality concept, we have two variants. We have the direct proportionality and we have the inverse proportionality, as we can see depicted on the screen. For the direct proportionality, we know we are given two quantities, x and y. We see that as x increases, y also increases, and vice versa. Whereas for the inverse proportionality situation, we find that as x increases, y tends to decrease, and vice versa also. Okay, so we see this kind of relationships everywhere in physics. It's a mathematical concept, but we see it in physics. For example, in the law of gravitation, we find the force of attraction between two bodies, inversely proportional to the distance between the bodies. And looking at the theory and also in practice, you find like a strong correlation between theory and practice. Also, in the study of electricity, we find that voltage is proportional to current, and we do not have any contradictions in all of these theoretical equations and in practice. Okay, However, in the study of seismic waves, we find some form of contradiction, which we have called a paradox. For example, given the expressions for compressional and shear wave velocities are shown in equation 1 and 2, if you look at it critically, you find that there's a proportionality relationship between velocities and densities in these equations. Okay, so you find that for the both cases, for both compressional and shear wave velocities, you find that they are both inversely proportional to the density. Okay, so we expect that as density increases, shear wave velocity should increase if density decreases. Also, compressional wave velocities also should decrease if density increases. So that's what we find from the theoretical expressions. Okay. However, in practice, we find something totally contradictory. Okay, this table here shows us typical values of densities and velocities of some known rocks. So what you see are also shown in the graph there. What we find is basically practically as density increases, velocity tends to increase. So this is what we find for almost all materials, except maybe for salt, where you have a situation, given the low density, you find that the velocities are unexpectedly high. However, even for salts, as density increases, you see also that that the velocities increase. So basically, this shows a contradiction or a paradox between what we have as the theoretical equations and what we find in practice. So essentially, this is the paradox we set out to see how we can resolve. Okay, so some of the things we noted from the situation that we have at hand. So practically, this is the expression we find. We find that both compressional wave velocities and shear wave velocities are directly proportional to the densities. So that's the paradox. So what are some of the things we are able to note from the situation is that as for any increment in density, we find that for the situation we have to occur, the numerators of those expressions, those theoretical expressions, must increase by some index factor of density. So that's what the equations tell us. Okay, drawing directly from that, we went on to note that it must mean that the elastic moduli, which are basically the parameters in the numerators of those expressions, must have some dependence on density, such that they can be represented in the form given in equation 3. Okay, so this basically is the form of expressions we set out to establish or to formulate for both the elastic moduli and by extension the seismic wave velocity, so as to resolve the seeming paradox we find in the expressions and in practice. Okay, so going forward, we set out to make the formulation of those expressions that can help us resolve that paradox. So we took the Castagnet's equation, which we all know, a relationship that gives us an expression that gives us a relationship between compressional and shear wave velocities, as we all use every now and then in our seismic analysis work. Okay, that equation is given in equation 4. Using that equation, we can go ahead to rewrite equation 2, which is the shear wave velocity equation. Okay, so writing that as shown in equation 5 and working through the algebra, we get the mu, which is one of the Lame's constants, in terms of density and compressional wave velocities as shown in equation 7. Okay, so having done that, if we now take that definition of mu from the previous session and use it to rewrite equation 1, and then walk through the algebra again, we find that we can then rewrite or write lambda in terms of density and compressional wave velocities as shown in equation 8. Okay, so going forward also, we recall the relationship given for compressional wave velocities and densities. In this case, we recall the one given by Al Ismail in 2017, which he coined after Gardner. So that's the original Gardner's equation. However, Al Ismail considered it and felt a more comprehensive expression for that relationship will be given as this. So we went ahead to use Al Ismail's proposition, with which we rewrote the equation for the expression for compressional wave velocity as shown in equation 9. Now, using equation 9 in equation 8, we went ahead to rewrite the expression for lambda purely as a function of density. Okay, we're able to write the equation of equation 8, which is the expression for lambda purely as a function of density. So you see lambda represented purely as a function of density in equation, that should be equation 10 there. Okay, and then going further, we also use the equation 9 in equation 6 in the expression for mu. Rewriting or working through the algebra again, we see that the mu now, one of the second Lamy constants, can be written purely as a function of density also, as shown in equation 11. So basically, these are the expressions, the kinds of expressions we set out to obtain, showing the dependence of these elastic moduli on densities purely. Okay, because this will help us to now understand what happens practically when you go out to measure seismic wave velocities and densities. Okay, so having obtained these expressions purely as functions of density, we went on to now extend it to the compressional and shear wave velocities as shown in equation 1 and 2. So substituting equation 10 and 11 into equations 1 and 2 and working through the algebra again, we find that the compressional wave velocity can then be expressed purely as a function of density as shown in equation 12. Okay, while the shear wave velocity can then be expressed purely as a function of density as shown in equation 13. Okay, so looking at these expressions, we see that this is what we really set out to do, just to be able to represent these moduli and shear wave and seismic wave velocities in such a way that we do not have a contradiction between what we find as the equations, theoretical equations, and what we measure in the field. Okay, so then going forward, we try to note some points or discuss some of the things we have found through our formulation. So first, we note that the expressions we have been able to come up with appear to be more intuitive. These are more intuitive velocity relationships, because if you go out to the field, what you see as density increases, velocity increasing, these equations try to express that more practically, and so they are totally devoid of that contradiction that we found in the initial equations. Okay, so we note also that the equations now appear more cumbersome. However, we believe once those empirical coefficients we have used in the formulation are found, once the numerical values are found and put in place, we believe those equations will become simpler. Also, we then note that the elastic moduli, all elastic moduli and geomechanical parameters are derivable or can be derived from as functions of density purely, which is physically simpler to relate to. Okay, density is easier to relate to than most of all these elastic moduli and geomechanical parameters. So we believe they are derivable from density. And also, one of the things we thought about is the validation of the formulation process. Okay, and we note that because of the formulation, we are able to use the original Gardner's model, which we showed previously initially, and what we arrived at was a compressional wave velocity equation that was exactly equal to Gardner's model. Okay, so we thought about that as a first pass validation for our process. Like we all know, Gardner was able to come up with that expression purely empirically. He made measurements and then looked for correlations and was able to postulate that equation. However, we have worked theoretically and looking at our endpoint, we were able to arrive at something that was equal to what he was able to get. So we see that as a first pass of validation for what we have done. Okay, and then we have projections for further work on this thought. So going forward, we think one of the first things that we need to go ahead to do is to accurately estimate these empirical coefficients. We have used A, C, M, N, and G. We need to be able to accurately estimate what those empirical, the values of those empirical coefficients. And also we need to be able to explain their physical importance. Okay, so we need to be able to decipher their physics so that we can place them properly in those expressions. Also, we need to go ahead to do numerical validation of this formulation. Okay, by that we mean we should be able to go out to the field, measure densities, and also measure other parameters. For example, the compressional wave velocities we have talked about, the shear wave velocities we have talked about. We need to be able to go out to the field, measure compressional wave velocities, measure shear wave velocities, and then measure densities, and then go back to the lab or to our workstations, and then use the densities we have measured to estimate those other parameters we measured in the field, and then correlate to see how well this formulation now matches the practice. Okay, so we need to be able to do that, but that should follow directly from the estimation of those coefficients accurately. Okay, and then importantly, we are looking at the possibility. So we need to work on the possibility, and also we are calling for others, interested people, to come into research into the possibility of estimating parameters of interest directly from density. By that we mean that this has the potential of taking away most of the very complex experiments complex and expensive experiments that we always go about to perform to be able to get some parameters. So if we are able to just measure density and then go back to our offices and sit down and begin to simulate geomechanical properties, be able to simulate elastic moduli and the rest of them, then you see that most of those experiments that we have to undertake to be able to describe or generate a model of the Earth may be taken away. So that's one of the thrusts of this work. So we are thinking we need to really research into that, and we call on interested parties also to look into this formulation and see how we can put our heads together and look for solutions to our problems as the petroleum community. Okay, so let me say thank you very much for listening. I'm sure I've not taken more than the stipulated time, so I thank you very much for listening, and I'm open to questions from the participants. So I'll hand over back to the moderator, Dr. Misha Akomodu. Thank you very much.
All right, thanks. Thank you very much, Dr. Dagogo. You did this in less than 20 minutes. So that's really great. That's about 15 minutes. So you've given us back a lot of time to begin to roll in the questions. So I would want to yield the floor now to every one of us. You have got questions. Please, there's a time to ask the question. I think there's a very first one here that is asking, I'll leave that to the section chair to respond to. Somebody coming in from Norway and is participating and asking if he or she would get a certificate or letter of attendance. So I'll leave that to the section chair to answer. Please, can we take questions? You can type your questions here too, and then I can read it out, or you just unmute
Mr.
yourself
Moderator,
and ask.
Can you hear me?
Yes, we can.
Peace Eba's hand is up, please.
Okay. Please, you can ask a question. I can't see. Yeah. Okay. Go ahead with your question, please. Please, Eba, please go ahead with your question.
Please, Eba, if you have a question, you can unmute your microphone and then speak. But if perhaps it was in error, you could just lower the hand. Sometimes it happens. Go ahead,
good
please.
morning. Good morning.
Good morning.
Okay, I want to thank the presenter. You've done some very good job relatively to the topic that is discussed. But I want to ask one or two questions directly to him now, vis-a-vis. I know that a lot of engineers are not right here. Maybe some few petroleum engineers or chemical engineers may be around. But what's your idea from your perspective of geophysics and geology right now, collaborating with areas in engineering like petroleum engineering, and then mathematics department of the sciences, and perhaps in the engineering, to be able to make some solid resolution to the topic under discourse?
Can you take the question again? Sorry.
What I'm saying is that what's your own idea? Other areas of engineering, like the petroleum engineering,
Yes.
chemical engineering, as well as the sciences of mathematics, to be able to resolve the current problem under discourse?
Well, yeah, the problem under discourse cuts across these disciplines for sure. But really, as geophysicists, let me take for geology, for instance. As geophysicists, we have some background in geology as geophysicists. Okay, so generally, I think geophysicists, we are already representing geology as it is. Okay, but yes, we need to collaborate with all of these other disciplines. The engineers also utilize these parameters we're talking about, the elastic moduli and the rest of them. When you talk about geomechanics, they also utilize those parameters. And in fact, mostly they have most of those equipments that we require to do most of this testing in the labs and all of that. So yeah, I think it's necessary for us to collaborate or to work together to see how we resolve some of these things so that we get easier solutions to our problems. Yes, because when you talk about drilling, geomechanical parameters are really necessary, are very important as far as drilling is concerned. So you drill safely. So yes, these are problems that concern the engineers, also petroleum engineers. So yeah, we need to collaborate. But as it is today, I cannot say I'm already working in collaboration with some of these parties. For now, this is just from the vine. We have not come into collaborations yet. So this is why we are calling for interested parties to see how they can be interested in looking for this kind of solution, so that we can then collaborate and see how we can move forward with the solutions. Thank you. I hope I've been able to
Yeah, thank you so much.
to justice your question. Yeah.
All right. I think the questions are around collaboration, which you've harped on. So thank you, P. Seba, for that question. Other questions, please, let's put them in the chat box. While we're waiting for those questions, Dr. Dagogo, I would like to ask you a question. Okay, there is a hand raised. Let me just take the question. When we look at the formulation, you will discover that we've got quite a lot of constants, or rather variables, that we need to determine. And in the course of your presentation, you did allude to the fact that you had already, you did a bit of comparison between the outcome of your density measurement and what Gardner actually gave. It would have been important for us to maybe if you maybe share this kind of meeting, so that you could whet our appetite that indeed we're on the right track to have shown us that comparison that you had made. So maybe you want to talk about it, the complexities in terms of the many constants or variables that we need to derive, and a bit more on the comparison that you have made with Gardner's relationship. Okay. And then after that, I will take the hands that is raised. Yeah, thanks.
Okay, thank you very much for that question. So basically, we have used empirical constants or empirical parameters that we have raised by both Castagna and Gardner. Okay, so this is Castagna's equation, where he used empirical constants or empirical coefficients A and C. Okay, we already have values that we use currently when we are to estimate or when we are to predict VS from VP. However, we know that those variables are basis dependent. So at this point, we are thinking, how do we go ahead to see if we can generate global values for these constants, such that we can have single values that can serve world over, or are we still going to maintain the Bayesian independence? And then if you are to maintain the Bayesian independence, we need to go ahead to maybe establish accurate values for these parameters. Okay. In the case of Gardner, also the same thing applies. He was able to come up with empirical coefficients, the M and N. Okay, so that's the original Gardner's equation. Okay, so we need to go ahead also, looking at the basic dependence of all of these parameters. We need to go ahead for ourselves to estimate accurately these parameters. Okay, so that's the first thing we need to do going ahead with this formulation. Okay, but then going to the second question, we really didn't compare our formulation with Gardner's formulation. What I tried to say was that using this original Gardner's formulation, Gardner gave that VP is equal to rho over m all raised to the 1 over n. Okay, if we had used this expression in our formulation, so if we had written this expression as equation 9 and then gone ahead to use it to derive lambda and go ahead to use it to derive mu, we would have arrived at the same expression as VP. So what would have obtained finally would have been VP is equal to rho over m raised to the 1 over n. Okay, that's what we are saying. So we are saying we see that as a first pass of validation for the work we have done. Okay, because we tried deriving these expressions that are devoid of the paradox theoretically using theoretical equations and all of that. But Gardner was able to do this empirically. He made measurements and was able to come up with correlations. That's how he arrived at this expression. So we believe, looking at the fact that we came through the theoretical route, and he came through the empirical route, and we are arriving at the same expression. We are thinking that's a way of validating what we have done. So that's not really a comparison. It's just a way to say that if we had used his own model, we would have arrived at the same. Well, if you want to call it the comparison, yes, it's fine. But we arrived at the same expression for the computational wave velocity using his model. Okay, so I don't know if that answers your question.
All right, thank you so much for that response. So we'll take Augustina's question.
There are also now some questions in the chat box, so maybe afterwards we can look at those.
Okay, let me see if we've got some.
All right. Good afternoon, everyone.
Good afternoon.
Yes, we are together in the office here. Can you hear me, please?
Yes, we can.
Hello.
Yeah, we can hear you.
Yes, yes, I've looked at the presentation very well. He has done justice to the equation aspect of it. I'm of the opinion that how do we apply it to this particular equation to resolving the velocity of issues in terms of migration and geopressure prediction? How do we apply all these arrays of equations in the application or in resolving a migration issue and geopressure prediction? Thank you.
Okay, thank you very much. So your migration issue has to do with variations in velocity. Your geopressure prediction, you also observe it using variations in velocity. So what we have done is, or what we are looking at is looking for a way to be able to determine our velocities accurately and easily. Okay, so we believe generally to obtain your velocities, you go out and maybe perform your seismic experiments, or you have to do downhole measurements and all of that. But we believe if there is a way which we think is easier to be able to accurately measure density than velocities. So this can affect all the problems you're talking about. If we can accurately measure densities, which are physically easier to relate to, then we can go ahead to sit down without stressing ourselves so much, without spending so much money. We can sit down to accurately simulate velocities. And if we accurately simulate velocities, I think all of these, the migration problem and the geopressure problem, we can easily identify them once our velocities are correct. So I think it has an effect on that. It has a ripple effect on all of those problems you're mentioning. Once density is easier to relate to, so if we can easily and accurately measure densities, if this formulation holds true, then it means we can also easily get our velocities, which is an indication of all of those situations. So once you have a geopressure point, your velocities will give you an indication of it. So once you have accurate velocities, then you can also accurately determine where you have those geopressure, overpressured positions. Thank you.
All right, so thanks so much. So we come to the question and answer here. So there are two questions here. We've got just about 7 more minutes. I think you should be able to do justice to this, Doc. It's question 1. What's the implication of the resolution of the paradox in seismic wave velocities via your mathematical deductions as elucidated in equations 12 and 13 in geopressure modeling? That question is from Johnson Elujoba. Yeah. You can actually click on the Q&A and also see the questions.
Yeah, it's also related to what Augustina just asked. So basically, we are showing the dependence of density on velocity of velocities on densities. Okay, so we are saying densities are easier to relate to practically or physically. Once you are able to accurately measure mass and volume, you are able to get density. And the experiments that you need to measure density, I think, are much less complex than the ones we need to measure other elastic moduli and even velocities. Okay, so the implication of these expressions is that once we are able to accurately determine our densities, then without much stress, without spending so much, we can accurately determine velocities, which is an indication of your overpressure. And it also gives you an idea of what your geomechanics is in the subsurface. Okay, so basically that's what it's about. That's the implication of it. Once you're able to easily, accurately determine velocities, then most of the other problems fall into place. Most of the solution to other problems fall into place.
All right, thanks. So the last one here says it's okay. From the practical work displayed, it shows that the shear velocity and others increases just as the density, but the expressions are inversely proportional. Do we say that the expressions are wrong? What's your thinking, sir?
So we may not necessarily say the expressions are wrong. So that's why we are able to look at the expressions and came up with ways of explaining what we see happening. Okay, so these are the expressions for compressional wave velocities and shear wave velocities. And we see, looking at this, looking at the velocities and densities only, per se, because the elastic moduli are not really constants, per se. As you go from one lithology to the next lithology, they also change. Okay, so they are not constants per se, but for us now, we are concentrating on the relationship between velocities and densities. Okay, so we see inverse relationships here. Okay, so we try to explain the difference or the disparity between theory and practice, which we are seeing, to say that it must mean that those elastic moduli have some dependence on density. That's the explanation of it. So yes, the equations show us expressions in terms of elastic moduli and density. So they are not necessarily wrong, but going ahead to now show the relationship between those parameters, the parameters in the numerator as functions of density now makes it clearer. So the equations are not, we cannot say they are wrong per se, but yes, they do not show us, they are not very intuitive practically looking at them. That's what I can say about it. They're not totally wrong, but formulating it in such a manner that those expressions in the numerators of the theoretical equations for the velocities, expressing them in terms of density now makes it clearer. So that's the point.
All right, thank you very much. Because of our time, okay. So our section chair is hands are up. Kano Magnus, please, your question, please.
All right, Dr. Mishak, thank you very much. I am actually not the session chair for the chapter coordinator.
Oh, sorry, please.
Thank you very much.
Okay.
Yeah, Dr. Dagogo, very, very many thanks for the bold stab at this scholarly subject and topic research, and then trying to solve these equations and all that. But this is the, this is the cradle, or this is the foundation for, if you will, seismology, wave propagation, understanding for wave propagation, and on that, many other things you're going to do in that space, be it core seismology, be it geophysics, be it petroleum geology or petroleum geophysics, would have to leverage that. And talking about the collaboration question that somebody asked at the start, it's fully wired into all of this. But something also, because we're dealing with the subsurface, we need to be very careful about is potentials for false positives, and that is something that I really wanted to ask about. If you took thoughts around false positives, meaning are there conditions that could help us to albeit they look physical, they look feasible, they look logical, but they could lead us to deriving wrong formula, wrong expression, or wrong relationships. Because now somebody asks about geopressure prediction and all that. If that basis is faulted, then whatever deductions, whatever extrapolations you're going to make would also be faulted. So are there false positives to really watch out for in all of this?
Okay, though I must confess your question is a little complex, but if I get it correctly, what I can say is that as it is with this formulation, whatever the initial formulations of velocities have been able to handle, this formulation should be able to handle. So whatever affected the velocities using the former expressions will also affect, or has the potential of affecting this formulation. Okay, so yes, the other thing I can say then is to say we have used, or we have leveraged on expressions derived by previous workers. For example, we have the relationship between shear wave and compressional wave given by Castainer. Okay, so we have not derived this expression, and we all of us in the industry also know that there are some shortcomings as far as this expression is concerned, which several other workers have tried to look into. Okay, so yes, there is, like you said.
Okay, Dagogo, let me help you. There is scope for more work. There is scope,
exactly,
right? So there is scope. Yeah. So well, you welcome more people to join the bandwagon to be able to push it, right?
Exactly.
All right.
Exactly,
so we are our time is up. So we want to thank you so much for taking time out to I just love the way you made your presentation to have allowed us enough time to have some discussion. So I would like us to, if it's possible, to unmute, to give a round of applause to our presenter today, Dr. Dagogo, if that is possible, virtually, as the case may be. And then thank you very much.
Thank you. Thank you.
So I finally hand over to the section, Napi. Thank you very much, chapter coordinator, and everyone who had given me the opportunity to moderate this session. Thank you very much as I sign off. Thanks. Yeah. Thank you.
Professor Modi Shedrack, how are you?
I'm not a professor yet.
I'm saying that upon you now.
All right, thank you very much, Dr. Meshach Omudu, for anchoring that session, and Dr. Nengi Dagogo for the presentation, and everyone as well for the engagement. I think it was a brilliant presentation. Yes, technical, but yet foundational for this science, which is very, very crucial in our industry. All right, so at this point, we're coming close to the end of a very brilliant session we've had today. We look forward to more coming. I would like to now formally hand over this part of the session, which will be also leading to the closing, back to our coordinator. And this time, the names shall be right. I call back Mr. Magnus Kanu to take the lead on this part, even as we begin to wrap up today's technical presentation. Mr. Magnus, please.
Amazing. Sorry. Yeah, amazing stuff. Thank you very much, Mr. Momudu, APCC. Thank you for expertly and masterfully confirm you can see my video. I don't like what my video is doing to me today. Can you see my video?
We can't see you.
Not exactly. It's not so clear, but it's
All
okay.
right. Okay. Okay. Let me not degrade the bandwidth further so that you can hear me clearly. Let me stop the video. But just to say a big thank you to everyone for this the participation and the energy represented in the room today. Beginning with. Don't worry, Prof. I'm coming to you. You're going to give us the closing remarks because I missed on my targets. I'm going to come to you, Prof. So a couple of things to say. Thank you, Dr. Dagogo. Thank you. Like I said, it's a bold stab at that subject, and you did very well. And we appreciate you deeply, Nape. We do appreciate you. Thank you for spending time, and for Dr. Mishak for also finding time to really also masterfully moderating the session, making it more enriching in the discussion and all that. And everyone for the questions asked, and some of you that were also not able to ask your questions. But hey, guys, let's keep the conversation going. This is to tee off this discussion. It's a technical group, technical platform. Let's continue to engage, let's continue to discuss, let's continue to sharpen one another and get better at our trade. So thank you very much. Very quickly, a couple of things I want to touch on, and then we wrap. I have a couple of announcements to make to us. While I recognize all our corporate members who have connected today, and even individual participants, you're very much welcome. And I trust that you were duly recognized. And if we missed you, it wasn't by design, it was inadvertent, but so bear with us. And very quickly, beginning with our YP group, we have a young professional group. They are extremely active, and they have a couple of plea, I want to bring to your notice. One is the young NAPE young professional technical capacity building for young professionals. The topic for that event is risk analysis and volumetrics of oil and gas industry, essentials for young professionals. And that event will be happening sometime 7th to 8th of July, 2023. But it's going to be with some financial registration of 5,000 naira per participant. This is an appeal from our young professionals to senior colleagues, to please sponsor someone, sponsor a YP to be part of it. That's why part of the reason we are here. The second one also along the same line would be holding 14th to 15th of October. And the topic is Introduction to Carbon Capture, Utilization and Storage, CCUS. This is very apt. We need to also begin to blood our young professionals into the energy mix, energy conversation, and not just oil and gas, And this is a door opener, in my opinion, into that space. So let's give as many young professionals as possible opportunity to be part of that. Also, some registration of a token 5,000 naira per participant. And we want our people, especially from Port Harcourt, young professionals, to be part of it. Then there is also another one that is planned for September, 8th of September. And there is also some registration. These are going to be posted on the platforms. As you see them, please look at them and subscribe to them. Now, I'm reminded that somebody from connected to us from Norway had a question. I want to assess it now to talk about it. And when I saw that chart, I was particularly pleased. I hope I can get to that. On the chart. Sorry. Yes, he was asking about certificate of attendance. Yes, or letter of attendance. Let me speak to you first and foremost that we are very grateful that you could connect all the way from Norway. That means that when we have virtual meetings like this, there is no boundary, no limitations. Anyone can connect from every part of the world, and that's to show you our global footprint. So for this, I think you need to connect. We need to connect offline. You can connect to the secretary or the publicity secretary or to myself, and we can take it offline. But let me tell you that once we determine that it's necessary for your work, especially as a research student, we can work with you and then give you a certificate for attendance. That shouldn't be a problem, right? So we can once we understand what you're going to use it for, we can now tailor it to that purpose. So please feel free to connect. So technically, directly to say to you that yes, that should work, and there shouldn't be any objection to that once we can determine, the necessity for that after discussing with you. So there are a couple of technical business meetings coming up again. This one is the. Please, if you're not speaking, kindly mute, please. This one is from the Oka-Owerri chapter, planned for the 22nd of June by 11 a.m. It's going to be a face-to-face physical meeting, and the speaker is one of our very own, one of our founding fathers, Professor Kemos to Onoha, on petroleum exploration and production in Nigeria, challenges and opportunities from the 2021 PIA, decarbonization demands and all that. So that's fantastic. Okay, thank you for projecting that. I have that. So go quickly to the next slide so that people can see that. I want to race through this. I don't want to take a lot of time on that. Are you displaying for me? I can go through it. There is the, yes, I'm done with that. There is a NAPE NMGS mini conference coming up, fantastic, coming up from the 6th to the 9th of September 2023, and the Venice University of Lagos. This is a very, very big one, epochal, topical for us, and you can see the themes. I can't read all of this, but a lot of publicity ongoing there, and the UAP chairman with our able president, national president, they are driving this aggressively, of course, being supported by the rest of the ESCO. I want you please to find occasion to see relevance in this and be part of it. Registration details are all there, and these things are being posted on all our social media handle. For flashing this is for you to pick them and then go in depth into them and consider them especially for yourself. Can we go to the next one, please? I am mindful of time, and that's why I'm racing. Good. The next one is also the biggie for the year, which is the 41st annual International Conference and Exhibition coming up Lagos from November 12th to 16th. Begin to plan right now. If you want to do paper presentation, I remember abstract submission is going to end sometime July 31st. Please look at this information and then plan your registration, depending on your category to be part of it. Very topical theme that we have there, very current, very relevant at times like this. The IOCs and NOCs are very much ready, corporate members, very much ready to be there to showcase. So find time to be part of it. Next one very quickly, please. We'll move to the next one, which is good. This is a call for abstract. We're taking abstracts right now. You can find the timelines for all of those. The deadline for submission is July 31st, abstract submission, and then they will contact you for your full paper submission, acceptance letters, and all that. And our own associate prof, Adekunle here, is the editor-in-chief. So he's driving that aggressively also. Right, can we go to the next one? Fantastic. So this is, I'm going to spend a little bit of some time here. A lot of people don't know why they should be part of, why they need to be part of a body like NAPE. It's important, a lot of times people just focus on the membership dues and they're not thinking around what is the value proposition, what is the benefit of membership to an association, a body like NAPE. There are activity areas that influence or impact individual members as well as students and the academia separately. For instance, you have the technical skills and career development. You benefit from that, whether as an individual member or as a student or as a member of the academia. We have the NAPE continuing education program, short courses and summer school that we organize. We have distinguished lecture programs that happen. We have the monthly technical meetings like we are holding today for the Port Harcourt chapter, Right. We have the young professionals activity groups you can be part of. We have career development seminars. These are the things that position you to have a say and play well in the energy sector, the energy industry that we all are moving into. And I like to think about the association as a part of, the elements and key players in the energy sector, not just the oil and gas, because of the way we are moving. There is the science and research, new ideas and discovery, that we have through the annual international conference and exhibition, the NAPE bulletin and conference proceedings, and the NAPE news. We also have educational support. We talk about NAPE biannual mini conferences. We have the ICEs, we have the library distinguished lecture programs, which you can have access to. You can have access to industry potential, employers as you interact, in this place. You can have leadership skills development. So there is a whole lot of value proposition that we need to, we can subscribe to being part and parcel of NAPE. And so that brings us to the membership dues. It's my desire, it's my drive, me with the ESCO, we are driving for the Port Harcourt chapter to be the chapter with the highest membership in the whole of NAPE. And we can make it happen. How does that happen? You here today, talk to somebody else to talk to somebody else. Let them understand these things we discussed today. Look at the high class, high caliber presentation we shared today. You may not readily find this kind in common places or in the classroom. You need to spend some time. At times you even need to pay to have this kind of discussion, to be part of it. So I want you to value what we have. And for student membership, just 2,000 naira per year, just 2,000 naira. If you see value in it, 2,000 naira is not something that can stop anybody. And for professionals, active member, just 12,000 naira per year, just like saying 1,000 naira per month. How much is a bottle of Coke right now? And you take more than 5 bottles of Coke for some people in a month. So, and for associate member, the same 12,000. Corporate members, no, that's a chicken feed, 50,000. And this drive is going to continue. And all of us are please welcome to be strong ambassadors of NAPE Port Harcourt chapter. We want to drive membership in a very big and bold fashion, because we know what our offer is not fake, it's not scam, it's real. So thank you very, very much. And that brings me to key things that we are also doing in terms of student chapter resuscitation. Thank you for getting to that. Thank you. Student chapter resuscitation plans and actually actions are on ground, afoot already to resuscitating or inaugurating some student chapters. We've paid visits to River State University, 2 of the HODs there, and we are in talks discussing with them to ensure that chapter is resuscitated. Likewise, Niger Delta University, they are very ready and expectant for their inauguration, and plans have reached advanced stage to get that to happen. It's going to happen sooner than you realize it. So let's be expectant, let's be hopeful around that. So this has been a very fantastic meeting. I am hoping that I did not forget anything. GS, you can boss me by the side if you think I forgot something, so that we can mention that as we begin to draw this meeting to a close. Right. So again, for the NAPE 2023 elections, nominations have been extended to dates. So I was silent on this because today is the deadline. So I don't know what anybody can do if you are yet to do something out to today, but just to let you know that this is what is happening in our community, something you can be proud of. Right. And then the NAPE awards. And the beautiful thing is that somebody doesn't sit in a place and then choose these things and decide this is the way these awards go. You have a say. You have a say making nominations, so that at the end of the day is a consensus, decision, or consensus award, or award based on consensus, decision, haven't, seen the impact and the contribution of such a person with regards to the themes being the categories of the awards being presented. So please feel free to take the information. You can make inquiries, reaching out to the people, advertised below, and make nomination. And it closes by June the 30th. Who says you cannot nominate yourself? Nominate yourself, and then we'll look at it whether it deserves a merit. Good. So The next one, please. Right, energy. Okay, energy is coming up at 9th to 13th of July 2023. Please find time to be part of it. Can we go to the next? Monthly technical meetings like these ones are usually sponsored by our corporate members. And I want to appreciate the likes of all the companies here represented who has, sponsored these technical meetings in the past. We have reached out to them again formally, writing emails, asking them to find, occasion and collaboration with us to really, sponsor. So you can see the people below there that can be reached. You can see the phone number to reach the NAPE Secretariat and then sponsor for Harcourt chapter meetings. So when you reach them, you tell them you want to sponsor Harcourt chapter meetings. But if you want to sponsor another chapter meeting, also let them know. But we desire that this happens. What has happened this month is that we have ingeniously, designed this month's meeting in such a way that it's not involving us a lot of cost, except probably that of data, and the virtual logistics we put in place. But usually we'll do a face-to-face meeting. And I like it. I like it that depending on the landscape, depending on what is happening, we can decide to hold a virtual meeting or a physical face-to-face meeting. And I can tell you that the one coming at the end of June or July is going to be a physical meeting. So watch out for it, look out for it. And so our corporate members, please, we are looking up to you for sponsorship to handle some of these. In some of the letters we sent to you, you can find the details in those. And if you need some more information, we'll be reaching out to you. And the last thing I hope this is the last thing I want to say now, is that we want to appeal to all our focal points in these companies, please, to help drive penetration of NAPI participation. And when we have meetings like this, let's drive, the publicity locally. Let's not just leave it that we've posted the publicity and then hope that people will get to see it and they'll be part of it. I don't think we need to talk about this exhibition floor plan now. That would not be a good use of our airtime, but this is also speaking to the NAPI AIC. Yeah. This is it. I just want to thank everyone. Any questions for me? Before I call on Associate Prof. Dr. Kunle to give us the closing words. And the reason for this, sorry, I'm putting you on the spot, was that we had tried to get one of our, representative of major corporate body to hold for today and give us a closing remark, but he is unavoidably absent. And so join me, guys. Let's make welcome in the absence of any other question for me, unless you can interrupt me now and then ask the question. If there is none, then I'd like to pass the microphone to Dr. Kunle while thanking all members of my ESCO. Thank you for your resilience, your diligence, for the collaboration, therefore, to put together, to pull this off is a great start. You can have reason to be happy with the effort you put in and the fruits that we'll receive from this today. Thank you very much, everyone. And let me welcome esteemed Dr. Kunle for the closing remarks.
Thank you, my protocol chapter coordinator. It's been a fruitful and insightful topic, and we want to thank our presenter, Dr. Tamunonengiyeofori, Dagogo, for that presentation, and also want to thank everyone, Momodu, Shedrack, and every member of the ESCO Protocol chapter. I'm saying thank you. It's a great time for us that at least we are able to have a presentation for the month, being the last day. And we hope that from the announcement our HCC has given, that we are all part of NAPI. NAPI belongs to every one of us, and we must keep it, especially our forthcoming election. We need more volunteers to take hold of this association. This is our own association. I want to thank you for everything you're doing. I won't say much because of time, but we hope that we'll be seeing more of every one of us in subsequent presentation. Thank you very much, and God bless you. Thank you, my PHCC. We'll see everyone in the next technical TM.
Thank you. Thank you very much, everyone. And have a beautiful rest of the day. Bye-bye.